Let's solve example number 3. For the given amplifier, determine the following: closed loop gain, output voltage, feedback voltage, current which goes through resistor R1, current which goes through resistor RF, and differential voltage. I'm going to start from calculating voltage gain. Formula for the voltage gain says closed loop gain of the non-inverting amplifier is equal to RF over R1 plus 1, where RF is equal 50 kilo ohms over 10 kilo ohms plus 1. So ACL is equal 50 kilo ohms divided by 10 kilo ohms will give me 5. Kilo and kilo will cancel out. 50 divided by 10 is 5, plus 1, which is equal 6. My voltage gain is equal 6. In order to find Vout, we're supposed to use the formula Vout is equal ACL times Vin, where my ACL is equal 6 and my Vin is equal 10 millivolts. 6 times 10 millivolts is equal 60 millivolts. This is my output voltage. Next, I have to find voltage F, my feedback voltage. What you're supposed to realize that feedback voltage is the voltage measured from the inverting input to the ground. Voltage from the inverting input to the ground. Also, you're supposed to realize that Vf is the same voltage as the voltage across resistor R1. So we can say that Vf is equal to VR1, where VR1 is equal to Vout times R1 over R1 plus RF. This is equal, Vout is equal 60 millivolts, R1 is equal 10 kilo ohms, and R1 again is 10 kilo ohms plus RF 50 kilo ohms. Close parenthesis. Vf is going to be equal 60 millivolts times 10 kilo ohms over 60 kilo ohms. Kilo ohms and kilo ohms will cancel out. We are going to reduce the fraction by 10, and I'm going to end up with 10 millivolts. My feedback voltage is equal 10 millivolts. Now, current which goes through resistor R1 we are going to find from the Ohm's law. R1 is equal voltage across resistor R1 over R1, where VR1 is equal 10 millivolts and R1 is equal 10 kiloohms, 10 millivolts over 10 kiloohms is equal 1 microamp. Remember that the operation amplifier has very large internal impedance, so the current is not going to go through very large impedances. Current always goes by the lowest impedance as is possible to reach the ground. So we can say that IR1 is going to be equal to IRF. So that's why I'm going to say that IRF is equal to IR1, which is equal 1 microamp. Differential voltage. Differential voltage we find from the formula V differential is equal voltage at non-inverting input minus voltage at inverting input. Voltage at the non-inverting input is equal 10 millivolts minus voltage at inverting input we found is equal also 10 millivolts. Ten millivolts minus 10 millivolts is going to give me 0 volts. My differential voltage is equal 0 volts. And this is my solution.